Hi everyone, I'm Sleepless Scientist. Tonight we're slipping into the coldest shadows of the hottest planet. You're standing somewhere that makes no sense on a silent crater rim of Mercury closest planet to the Sun, and yet under your boots, there's ice. Yes, ice. It's like finding a snowman in a microwave. This planet baked by solar radiation scorched enough to melt lead still manages to hide shimmering sheets of frozen water deep inside its polar craters. You're not hallucinating. Not yet anyway. Mercury doesn't really have an atmosphere, which means there's nothing to trap heat or spread it around. So while the daytime side sizzles at 800 degrees, 130 degrees Celsius, the permanently shadowed regions at the poles can drop to 330 degrees Celsius, 200 degrees Celsius. It's the ultimate two-face. You step from one side of the rock to the other and basically explode or freeze solid. And somehow in those unlit pits, untouched by sunlight for billions of years, water ice lies in wait. Scientists still debate whether it was delivered by comets' asteroid collisions or formed from hydrogen and oxygen in the rock itself. But here's the mind-bender: no weather, no clouds, no liquid water. And yet frozen evidence of water stubbornly exists. Like the universe planted it there on purpose just to mess with us. You shuffle forward, boots kicking up silvery gray dust, staring into the deep black bowl of a crater. There's no wind, no sound. You feel like you're inside an enormous broken watch. Time here doesn't tick, it just lingers. The sun hangs low on the horizon, never climbing far, like it's watching from a distance. And the shadows, they don't creep. They sit immobile, eternal. Now imagine this: Mercury doesn't even rotate once per orbit. It has a 3-2 spin orbit resonance, which means it spins 3 times for every 2 orbits around the Sun. So if you camped here, you'd experience 1 day every 2 Mercurian years. Time on Mercury is weird, cruel, and mostly irrelevant. You're not counting hours here. You're surviving thermonuclear sunrises and absolute zero nights. Fun side note: Mercury is shrinking. Not metaphorically like your work motivation after 2 p.m., but literally. It's cooling on the inside, and like a raisin drying out, its crust is cracking and folding. You might be walking over freshly formed cliffs called Lobot Scarps, younger than some Egyptian temples. Also, here's your irrelevant fact of the night: Mercury has a tail. Yes, a planetary tail. It's made of sodium atoms blasted off the surface by solar radiation and dragged behind like some giant invisible comet ponytail. So technically, Mercury glows faintly in ultraviolet light, like a glow stick that's just refusing to die. But good luck seeing that from Earth. You'd need a telescope and a lot of hope. The Mercury lander we're imagining doesn't exist yet, but one day it might. And if it does, maybe it'll bring back ice samples from a world that shouldn't have water in the first place. Maybe we'll find organic molecules. Maybe we'll find nothing. Either way, we'll still whisper about the quiet contradiction of Mercury blazing and frozen, lonely and magnificent. So here you are, hovering above an icy pit in the innermost inferno of our solar system. You lean forward, peer into the inky depths, and for a moment, it almost feels like the crater is looking back. I'd love to know where in the world you're listening from and what time it is for you. Let me know in the comments below. I'm always curious where these quiet little science stories are drifting to, and if this video helped you while you were there. Now relax, take a deep breath, and join me gently on this evening's journey. You're drifting now off the surface of Mercury and out into the sulfur-colored clouds of the second planet from the Sun. Welcome to Venus. She's beautiful, luminous, romantic even. But don't get too close. You'd dissolve, literally. You float just above the thick atmosphere, peering down at a world wrapped in carbon dioxide and sulfuric acid hot enough to melt lead. The surface temperature is over 860 degrees 460 Celsius, and the pressure would crush you like a soda can. Venus doesn't just want you dead, it wants you artistically flattened. But that's not even the weirdest part. Here's the fact that makes scientists rub their temples: Venus spins backward, and slowly. So slowly, in fact, that a day on Venus, one full rotation, takes 243 Earth days. Meanwhile, its year is only 225 Earth days. Yep, a day is longer than a year here. You could eat breakfast, lunch, and dinner, celebrate your birthday, and still be stuck in the same endless afternoon. Also, its rotation is retrograde, which means the sun rises in the west and sets in the east. If you were standing on the planet somehow not boiling alive, you'd witness the most sluggish, backward sunrise imaginable, like the universe hit rewind, but only for one planet. Scientists still debate why this happened. Did a giant object slam into Venus and reverse its spin billions of years ago? Or did the dense atmosphere somehow torque the entire planet over millennia? Either way, Venus is the celestial oddball that refuses to play by solar system rules. She's got her own schedule, her own style, and frankly, she seems like the type to ghost you mid-orbit. And then there's the weird possibility that Venus used to be more like Earth, temperate, maybe even watery. Some simulations suggest Venus had oceans billions of years ago before a runaway greenhouse effect turned it into the solar system's pressure cooker. You wonder what it was like before the skies turned yellow and toxic. Did it ever feel like home? Here's your irrelevant but wonderful fact. A day on Venus is so long that if you had a mechanical wristwatch, it would run slow due to the gravity difference and extreme heat. But it wouldn't matter, because time means nothing here. Time is soup. Melting, stinking, sulfuric soup. Yet orbiting above all that chaos, there's a strangely peaceful rhythm. The cloud layers swirl in slow motion. Lightning flickers deep in the atmosphere. A wind rips through the upper clouds at over 200 mph faster than hurricanes on Earth. The surface might be still, but the skies are alive. Venus might be geological death, but meteorological poetry. Let's take a moment to talk about something quietly unsettling. Despite the planet being basically uninhabitable on the ground, scientists have spotted chemical anomalies in the Venusian clouds, traces of molecules like phosphine that could hint at microbial life. Maybe not. Scientists still debate this fiercely. The data's inconclusive, but the hope, oh, it's alive and well. One day, balloon probes may hover in Venus's upper atmosphere, where temperatures are only 86 degrees 30 degrees, and the pressure is like Earth's surface. That's the Goldilocks zone, strangely not on the ground, but in the clouds. If alien microbes are anywhere near us, they might be floating above the death planet, soaking up sulfur and confusing every biologist back home. Meanwhile, back in your dreamlike descent, your visor fogs up with phantom mist. You're imagining what it'd be like to fly through Venus's skies in a solar-powered Zeppelin, watching the planet's thick yellow blanket ripple beneath you. It's strangely serene, until you remember what happens if you drop even 1 meter too low. Still, Venus doesn't feel evil. She just feels misunderstood. Like a goddess who once loved life but now wears poison perfume and doesn't return your texts. So yes, the planet spins the wrong way. Its day is longer than its year, and its past might be more Earth-like than we ever expected. But don't let any of that distract you from the fact that right now a full solar rotation is dragging itself across the sky, and it'll still be rising long after you've fallen back asleep. Now you drift farther from the sun, out of the acidic clouds of Venus, and into the pale blue dot you call home. But let's be real, Earth is weird, and nothing makes that clearer than the oversized, overly emotional rock that hangs in your sky every night. The moon. Let's say it plainly, Earth's moon is too big. Astronomically speaking, it's weirdly enormous for a planet our size. No other rocky planet in the solar system has anything like it. Mercury, no moons. Venus, also zero. Mars, two little asteroid-sized chunks. But Earth. We've got this massive, round, perfectly photogenic moon just hanging there, like it owns the night. Scientists still debate how it got here. The leading theory, called the giant impact hypothesis, says that billions of years ago, a Mars-sized object named Theia slammed into proto-Earth. The collision was so violent it sprayed molten rock into orbit, which eventually coalesced into the moon. Basically, our moon might be made of Earth's guts. Romantic, right? But the exact details don't line up perfectly. The moon's composition is strangely similar to Earth's mantle, but not Theia's theoretical core. And the math around orbital dynamics is still fuzzy. Some suggest multiple impacts formed a series of temporary moons that merged. Others argue the moon formed alongside Earth and just wandered into place. Still, no one agrees completely. It's like arguing with someone about who really invented pizza, only the debate has been going for 4.5 billion years. But here's the kicker. Without that suspiciously large moon, you probably wouldn't be here. Its gravity stabilizes Earth's axial tilt, keeping seasons regular and climate relatively stable. Without it, Earth might wobble chaotically like a toddler on sugar swinging between ice ages and tropical hellscapes. You blink up at it now, floating just above the moon's pockmarked surface. The gray regolith is soft and powdery beneath your boots. And even though it's silent, you can almost feel the echoes of Neil Armstrong's footprints. They're still here. There's no wind, no rain, no erasing time. Just an eternal hello from 1969. And the moon is still slowly drifting away from Earth, about 1.5 inches, 3.2 per year. Someday, in a few 100 million years, solar eclipses will no longer be perfect. The moon will look too small to fully cover the sun. Future skywatchers will miss out on the eerie glory of a full corona. Lucky for you, you live in the golden age of celestial drama. Irrelevant but delightful moon fact. Apollo astronauts reported a mysterious smell after moonwalks, something like spent gunpowder. Moon dust clung to their suits, clung to their boots, clung to everything. And once inside the lander, it gave off a burnt, metallic aroma. One small sniff for man. Meanwhile, the moon has its own surprising quirks. For example, it rings like a bell when struck. During the Apollo 12 mission, NASA crashed a spent lunar module into the moon. The seismic sensors they'd planted picked up reverberations lasting over an hour. It didn't make sound, remember, no air, but the vibrations hinted at an unexpectedly rigid interior. Some people ran with that and claimed the moon might be hollow. Spoiler, it's not. Still, that ringing moon mystery sparked decades of fun conspiracy theories. And let's not forget the moon's darker side. Literally. The far side of the moon, never visible from Earth, is cratered, silent, and strange. It's not actually dark, but it feels that way. Like the set of a sci-fi horror movie waiting for the opening credits to roll. Lunar orbiters have captured haunting images of that lonely terrain. If the moon had a basement, this would be it. So here you are again, balanced between absurdity and awe. A planet with a moon too big, born from a cosmic sucker punch, stabilizing life, influencing tides, and occasionally giving humans the urge to howl. You watch it float, motionless against the blackness, and realize it's not just a satellite. It's a storyteller, a memory, a silent guardian of Earth's wobbly little dance through space. Leaving the moon behind, you glide toward the blood-red sands of Mars, where the sky is tinged with butterscotch and the ground looks like a painter lost control of the red palette. But tonight, you're not here to gaze at sunsets or imagine lost civilizations. You're here to stand at the feet of a monster, Olympus Mons. It's not a mountain. It's not even a volcano in the way you think of volcanoes. It's a continent-sized colossus looming 6 miles 22 kilometers high, nearly 3 times the height of Mount Everest. Its base sprawls like a city that decided to become a continent, covering an area roughly the size of Arizona. And it's extinct. Probably. Scientists still debate whether Olympus Mons is truly dead or just sleeping. Its last eruption might have happened only a few million years ago, which in geologic terms is like last Tuesday. Some evidence hints that magma may still be simmering below biding its time. Honestly, Olympus Mons might just be doing what you wish you could do, napping forever under a blanket of ash. As you float closer, the scale messes with your head. There are no sharp ridges, no jagged peaks like on Earth. Mars has lower gravity and there's no plate tectonics, so lava could just pile and pile and pile, gently oozing instead of explosively erupting. That's why this thing is so big it never moved. It's the equivalent of squeezing toothpaste on the same spot every day for a billion years. You land near the caldera, the cratered summit. It's like standing inside a sleeping giant's mouth. The air is so thin, it's practically a rumor. You could jump 3 times higher here, though you'd still need a spacesuit unless you enjoy suffocating while sunburning at the same time. Odd fact of the night. There are some lava tubes beneath Olympus Mons that could fit entire cities inside. Scientists are eyeing them as possible homes for future Martians. Or let's be honest, for introverts who finally want to be left alone. Mars has its own collection of weirdos too. Its largest canyon, Valles Marineris, is over 2,500 miles long, longer than the United States is wide. And between that and Olympus, Mars seems like a planet that tried really hard to be dramatic. You want mountains, bam. You want a canyon, hold my water. Oh, and about that water. Mars used to have it. Oceans, rivers, rain, maybe even snow. Now most of it's locked up in ice caps or hidden under the surface. But streaks on the cliffs and salt-rich deposits suggest that liquid water might occasionally still appear today. Maybe. Scientists still debate what happened, why the atmosphere escaped, why the water ran away, whether life once existed here. Mars is full of questions with half answers and dusty regrets. And yet Mars isn't completely dead. It still has seasons. It still has weather. It even has dust devils twisting red cyclones dancing across the surface like ghost tornadoes. They've been captured by rovers and orbiters alike, throwing Martian dust into the air with eerie grace. You stand there at the rim of Olympus Mons, watching the horizon curve beneath the massive volcano. It's almost funny. Back home, climbing a mountain like this would take weeks and cost you several pairs of toes. Here, with the low gravity and no wind resistance, it would be like hiking in slow motion through a silent museum built by lava. And the view. If the sky were clear enough, you'd see halfway around the planet. Not because your eyes got better, but because Mars is small and this mountain is absurdly tall. You could lie on your back and look out over a horizon that doesn't feel real. Before you go, here's a moment of stillness. You close your eyes, and for a second, imagine the mountain breathing. A low, ancient breath of warm rock shifting below. You wonder if Olympus Mons dreams. You wonder if one day it'll wake. Now hold tight, because you're about to leave Mars's rusty dust and dive into something huge. Not big, not even colossal. We're talking cosmic heavyweight champion of the solar system, Jupiter. You approach it slowly, but it still swells in your view like it's leaning in to say, "Yeah, I'm the boss." And it is. Jupiter is so massive that it doesn't orbit the Sun in the same way other planets do. Its center of mass with the Sun actually lies just outside the Sun's surface, meaning technically, they both orbit a point in space between them. The Sun doesn't even have the nerve to keep Jupiter on a leash. But you're here tonight for something less poetic and more terrifying: Jupiter's magnetic field. It's a beast. Earth's magnetic field is what lets your compass work and protects your Wi-Fi-addicted brain from solar radiation. Jupiter's magnetic field, about 20,000 times stronger. If Earth's field is a gentle umbrella, Jupiter's is a full-on riot shield made of plasma and rage. Scientists still debate exactly how this magnetic monster works. Deep inside Jupiter, beneath its cloud layers of ammonia and hydrogen, there's likely a swirling ocean of metallic hydrogen. Yes, metallic hydrogen. Under such pressure, hydrogen atoms are squeezed into a liquid metal that conducts electricity. This rotating, churning core generates a magnetic field so large it stretches over 12 million miles into space. That's enough to encompass Saturn's entire orbit, depending on how you count it. And guess what? If you were somehow flying near Jupiter's magnetosphere without proper shielding, your laptop would fry instantly. Your phone gone. Your nervous system also probably gone. Radiation belts near Jupiter are so intense they've damaged spacecraft just trying to take a peek. Juno, the current orbiter, has to duck and weave through the least dangerous regions, like a spy on borrowed time. Let's lighten it up with your irrelevant but awesome fact: Jupiter's magnetic field causes auroras way more powerful than Earth's. But because it has no solid surface, those glowing curtains of plasma flicker endlessly over cloud tops that swirl like oil on water. The colors unreal. Mostly ultraviolet, but still, if you could see them with your eyes, you'd probably cry a little, quietly, with space tears. You float now above the North Pole of Jupiter, and the clouds here are weird. Instead of one big swirl, there's a hexagonal jet stream made of 8 cyclones spinning in a geometric ballet. It's hypnotic. No one knows exactly why it stays that way. Nature doesn't usually do shapes like that unless it's showing off. Then, of course, there's the Great Red Spot. You float lower down to the massive crimson swirl that's been raging for at least 350 years. That's longer than the United States has existed. It's a hurricane so big that 2 Earths could fit inside. And while it's shrinking slowly, it's still going strong, defying predictions, models, and logic. Some scientists say it's a remnant of older, more turbulent times. Others believe it's powered by heat rising from deep below. But no one really knows why it refuses to die. The Great Red Spot is the solar system's angriest zit, and Jupiter won't stop poking it. You imagine standing there above the clouds. Of course, there's nothing solid to stand on. Jupiter is a gas giant. If you tried to descend through its atmosphere, you'd sink for thousands of kilometers, getting crushed, cooked, and dissolved along the way. By the time you reached anything resembling a core, you'd no longer be yourself, you'd be physics soup. And yet, despite all that chaos, there's something soothing here. The endless clouds, the circular storms, the sheer gravity of it all. Jupiter doesn't just spin, it commands the solar system. Its gravity shepherds comets, captures moons, and even flings rogue asteroids into the sun like it's taking out the trash. Speaking of moons, we'll get to those. Oh yes. Jupiter has over 90 confirmed satellites, and some of them are so wild, they deserve entire bedtime stories of their own. But for now, you float in the gentle hum of Jupiter's magnetic wrath. The invisible field buzzes softly around you like an electric halo. You drift weightless and small beside the giant that protects and threatens everything in its orbit. And as you look down at the swirling planet, you realize you're seeing something that can't be truly understood, only respected. Revered. Maybe feared a little. It's not just a planet. It's a god in motion. You drift now from Jupiter's swirling titanic mood, swings into something lighter. Not in drama, but in literal weight. Look, there it is, floating like an impossible balloon in the blackness. Saturn. Of course you know the rings. Everyone knows the rings. They're what you think about when you think space or when a graphic designer gets bored in a science textbook. But Saturn isn't just about the bling. Tonight you're here for something that sounds like a joke, but is in fact completely true. Saturn could float in a bathtub. Let that sink in. If you had a bathtub big enough, a cosmic-sized clawfoot monster, Saturn would just bob gently on the surface. Why? Because its average density is less than water. It's around 0.69 grams per cubic centimeter, which is nice and also bizarre. That doesn't mean the planet is fluffy. Well, actually, yeah, it kind of is. Saturn is made mostly of hydrogen and helium, just like Jupiter, but with even less mass to compact all that gas into something solid. In other words, Saturn is like Jupiter's dreamy, aloof, younger sibling who does yoga and doesn't care if you notice. As you descend through the outer atmosphere, you feel the difference immediately. The clouds here are calmer, paler, subtle ribbons of cream, beige, and soft gold. There's beauty, but also restraint. Saturn doesn't need to scream like Jupiter. Saturn whispers. But underneath that whisper is something massive. Saturn is over 9 times wider than Earth, and if you stood on a platform floating in its upper atmosphere, which, let's be honest, is impossible, you'd weigh only about 91% of what you do on Earth. Not a lot, right? But here's the thing, Saturn's mass is 95 times Earth's. So why do you weigh less? It's because the planet is so wide, the gravitational pull is spread out like someone trying to hug you with foam noodles instead of arms. You're being pulled in all directions, but not hard enough to matter. It's gravitational gaslighting. Now let's talk about those rings, because they deserve it. They're not solid. They're not smooth. They're made of ice and rock chunks ranging from grains of sugar to school bus-sized boulders. And they orbit Saturn in perfect razor-thin lanes, only about 10 meters thick in some places. That's nothing compared to their width, which can span up to 175,000 miles. And yet, brace yourself, they're temporary. Scientists still debate how long the rings have been around. Some evidence suggests they may be as young as 100 million years. That's basically yesterday, cosmically speaking. The dinosaurs might have seen Saturn without rings. We might be living in a rare blip of time when this planet just happens to look stunning. Worse still, the rings are disappearing. Slowly, the ice particles are being pulled into Saturn by gravity, forming what's known as ring rain. In another 100 million years, they could be gone entirely. Saturn will still be Saturn, but naked. A little awkward. Still beautiful, just different. Your irrelevant Saturn tidbit of the night. The planet spins so fast that it's visibly flattened at the poles. Its day is just over 10 hours long. That's absurd for a planet its size. It's like watching a beach ball spinning on a blender. That rotation bulges the equator outward, making Saturn look more like an egg than a sphere. And then there's the hexagon. No, that's not a misprint. At Saturn's North Pole is a massive, persistent hexagonal storm system, first spotted by Voyager and later studied by Cassini. It's a perfect 6-sided jet stream about 20,000 miles across. Scientists still don't fully understand how this geometry forms and persists. Nature hates straight lines, usually. But Saturn draws polygons in the sky like it's got a ruler and some flair. You drift above it now, the rings curving below, casting shadows across the pale atmosphere like eyelids half shut. The hexagon spins slowly beneath you, swirling with blues and violets that don't show up in Earth telescopes. It's mesmerizing. It's math. It's art. Saturn has over 140 moons, Titan being the largest and maybe the most mysterious, but let's not get ahead of ourselves. Just for now, just for tonight, you hang there, suspended in Saturn's lazy spin. You imagine that colossal bathtub again, and you wonder not for the first time if Saturn floats. Why do you feel so heavy? You blink, and now you're tilted. No, wait, the planet's tilted. Or maybe both. You're approaching Uranus, and the first thing to understand is this: it rolls. Not spins, not turns, rolls like a bowling ball someone pushed across a cosmic carpet. Its axis of rotation lies nearly sideways, tilted at 98 degrees. That's not a typo. Most planets spin like tops. Uranus, it spins like someone knocked it over, and it just decided to go with it. Scientists still debate what caused this. The leading theory is that long ago, something big, maybe even Earth-sized, smashed into Uranus and knocked it onto its side. But some models suggest a series of smaller collisions might have done the job more subtly. Either way, it's the solar system equivalent of getting sucker punched and turning the other cheek for 4 billion years. You float just above the bluish haze of its atmosphere now. It's quiet here. Weirdly quiet. The planet's cloud tops are soft tones of turquoise and sea glass green, tinged with methane that absorbs red light and gives Uranus its signature look. It's beautiful, subtle, like the universe painted it in watercolor and then forgot to add details. And despite the pastel palette, this place is brutally cold. Uranus has the lowest average temperature of any planet in the solar system, around 371 Chav, 224 degrees. It's even colder than Neptune, which is farther out. Why, no one knows for sure. Scientists still debate whether Uranus's odd tilt affects how heat escapes from its interior, or if something weirder is going on inside. You hover above the South Pole, which, depending on where you're standing, is sometimes pointed directly at the sun. Seasons here are extreme. Each pole gets 42 years of constant sunlight, followed by 42 years of darkness. You think your winter's bad, try a night that lasts 4 decades. Irrelevant and delightful side note. Uranus's magnetic field doesn't line up with its spin. Not even close. It's tilted 60 degrees from the axis and offset from the center. That means the magnetic field wobbles around like a drunk umbrella, creating chaotic auroras that don't match the planet's orientation at all. If you were holding a compass, it would just quietly give up. Also, Uranus smells bad, like objectively. When scientists analyzed its upper atmosphere, they detected hydrogen sulfide, the same stuff that gives rotten eggs their delightful aroma. If you could stick your head out of a spacesuit for even a second, which you shouldn't, your last breath would smell like a sulfur fart. Dignified, really. But despite all that, Uranus has rings too. Faint, narrow ones, less flashy than Saturn's, but mysterious in their own right. They're dark, composed mostly of large particles, and possibly formed from shattered moons. You might miss them with the naked eye, but they're there circling the sideways planet like secret bodyguards. And speaking of moons, Uranus has over 24 of them, many named after Shakespearean characters Miranda, Titania, Oberon. Miranda is especially strange, with a Frankenstein surface patched together like someone tried to build a moon from leftovers. Giant cliffs, canyons, ridges. It's got the highest known cliff in the solar system. Verona Rupees, a wall of rock over 12 miles high. If you jumped off it with proper equipment, obviously it would take you over 10 minutes to hit the ground. Uranus doesn't shout, it doesn't dazzle, it lurks, a rolling blue-green marble that quietly redefines what a planet can be. No dramatic storms, no glowing spotlights, just a long, silent roll through the cold with a magnetic field that won't behave, rings you can barely see, and a tilt that defies logic. As you float above it, a thought crosses your mind. If Uranus could talk, it wouldn't yell. It'd probably whisper something cryptic, then roll away before you could ask for clarification. And in that moment, watching its slow spin under a dim sun, you find yourself oddly comforted by it. It doesn't want to be understood. It doesn't need to explain. It just is. If Uranus rolls like a shy poet in a starry library, Neptune is its furious twin, the stormy sibling at the edge of everything howling into the cold. And tonight, you're drifting above the windiest planet in the entire solar system. Yes, Neptune. The farthest of the 8, the loneliest gas giant. Out here, sunlight is so weak, it's barely more than a bright star in the sky. You could stretch out your hand, and the warmth of the sun wouldn't even reach your fingernails. And yet, somehow bizarrely, this frigid, distant planet is home to winds that scream at over 1,200 miles per hour. Let that sink in. Faster than the speed of sound on Earth. Enough to strip paint off a spaceship. No one fully understands how or why. Scientists still debate what fuels this madness, how Neptune generates such kinetic rage with so little sunlight to power it. The atmosphere must be doing something deep and strange. It's like a planet made of cold anger. As you drift over its topaz blue clouds, the texture surprises you. Neptune isn't smooth. It's wild. Bands of storm systems whip around the equator, and there are violent inky vortexes called dark spots, massive storms like Jupiter's Great Red Spot, but moodier and less permanent. Some vanish in just a few years, one even reversed direction. Neptune changes its mind like a teenager who's just discovered coffee. But it's not just chaos. It's stunning. That color. The deep, vibrant blue. It's not fully understood either. Methane plays a part, sure it absorbs red light, but scientists think there's something else in the atmosphere enhancing the hue. We don't know what. It's still one of the most vivid and unexplained colors in our solar system. You get the feeling Neptune likes to keep secrets. Here's a deliciously irrelevant fact: Neptune has an internal heat source that radiates more energy than it gets from the sun. Unlike Uranus, which seems oddly quiet inside, Neptune radiates warmth like it's angry at the void. Some theories suggest leftover heat from its violent formation. Others think tidal interactions with its moons might play a part. But really, no one's sure. Speaking of moons, Triton. Oh, Triton. It orbits Neptune backwards, retrograde in a direction opposite to the planet's rotation. This is super weird. No other large moon in the solar system does this. Scientists believe Triton was a Kuiper Belt object, a wandering icy body that got too close to Neptune and was captured by its gravity. In the process, it may have destroyed or ejected Neptune's original moon family. Savage. But Triton's weirdness doesn't stop there. Its surface is young and active with geysers that shoot nitrogen ice into space. The terrain looks like it was melted and refrozen into bizarre ridges and pits. And it might even have a subsurface ocean. Imagine that a frigid moon orbiting backwards, spraying ice and quietly hoarding water beneath its crust. You float now, watching Neptune spin fast, by the way, just over 16 hours for a full day, and listen to the imagined roar of its invisible tempests. If you could parachute into the upper atmosphere, you'd be shredded by winds faster than bullets, in an environment colder than liquid nitrogen. Still want to try. Because Neptune, despite all that hostility, doesn't feel cruel. It feels epic. like a blue opera howling from the edge of time. A reminder that even the farthest places have drama. Even the coldest planets burn. It's easy to forget Neptune exists. It's too dim to see with the naked eye. We've only flown by once, Voyager 2 in 1989. One pass, one snapshot. And we're still piecing together what it was trying to tell us. And now you're here, floating above it, listening to winds no ear has ever truly heard, watching storms no one else is watching. There's something romantic about that, a kind of solitude that feels like grace. As Neptune spins beneath you, its rings, yes, it has rings, faint and dusty, twinkle briefly before fading into shadow. You catch one last glimpse of Triton gliding backward as if waving goodbye in reverse. You don't know what Neptune is hiding. But maybe that's the point. Past Neptune, past the orbit of anything with real PR representation, you drift into the underdog of the solar system, Pluto. And yes, we're still talking about it. Planet or not, it earned its place in this dreamy parade of weirdos. You float closer and immediately feel it. Pluto is small, like really small, barely over 1/400 miles in diameter, smaller than the Moon. You could drive across it in less than a week if you know it had roads, or oxygen, or gas stations. But despite its tiny size, Pluto manages to be one of the most emotionally confusing places in space, because it has a heart. Not a metaphorical one, though you're welcome to get misty about it, but a literal giant heart-shaped glacier on its surface. Officially called Tombaugh Regio, it's made mostly of nitrogen ice, and it's enormous. You hover above it now, watching its soft, pale plains ripple beneath a shadowy, frozen sky. And here's the thing, that heart is alive. Not with creatures or romance, but with motion. The left lobe, Sputnik Planitia, isn't just a patch of frozen flatland. It pulsates. Convection currents deep within cause the ice to slowly churn and move over time. Glacial flows ripple like frosting pushed gently across a cake. It's as if Pluto is breathing, slowly, coldly, but undeniably. Scientists still debate how this is possible. Pluto doesn't generate much internal heat. Its heart seems to move anyway, powered perhaps by radioactive decay or pressure from a subsurface ocean. Yes, that's on the table. Some think Pluto has liquid water deep beneath its icy shell, protected by ammonia or exotic antifreeze compounds. And if that's true, you guessed it, we have to consider that life might exist in that hidden sea. Pluto. The little guy. The rejected planet. The maybe not cradle of alien microbes. But it gets weirder. Pluto has a moon Charon that's so close in size the two bodies actually orbit a common point in space outside Pluto's surface. Technically, they're a binary system. Imagine dancing with a partner your own size while holding hands across 12,000 miles of frozen silence. That's Pluto and Charon. And Charon's not just a passive satellite. It's got its own canyon system much deeper than the Grand Canyon. It has ice cliffs, cryovolcanoes, and dark smudges at the poles that some scientists have poetically called Mordor. Tolkien would be thrilled. Pluto's surface is a patchwork of contradiction, some areas smooth and new others battered and ancient. There are mountains made of water ice towering like frozen granite. There are pits and scars that tell of impacts, but also signs that something is still active here. Oh, and Pluto has an atmosphere. Didn't see that coming, did you? It's a thin envelope of nitrogen, methane, and carbon monoxide that expands when Pluto is closer to the Sun and collapses as it moves away in its long elliptical orbit. That's right, Pluto breathes too. Not like Earth, not like life, but in its own frozen lung kind of way. And let's throw in your irrelevant but hilarious fact of the night: Pluto's orbit sometimes brings it closer to the Sun than Neptune. Between 1979 and 1999, Pluto was officially our eighth planet, bumping Neptune down a peg. Neptune didn't care, of course. It's too cool to fight. But still, Pluto was technically crashing the inner circle. Now Pluto's back in its proper place, orbiting at an average distance of 3.7 billion miles from the Sun. That's over 5 hours of sunlight delay. If you flipped a light switch on the Sun, Pluto wouldn't know until lunchtime. And then there's New Horizons. In 2015, this little spacecraft made a flyby that changed everything. For decades, Pluto had been a blur, a pixelated smear in textbooks. Then suddenly, there it was, a world, with mountains, with a heart, with secrets. New Horizons captured images of a planet that shouldn't be this complex, shouldn't be this alive. But Pluto doesn't care what it should be. Neither do you right now. You hang motionless over Sputnik Planitia, watching faint frosts glimmer like powdered sugar under a black sky filled with faraway stars. The Sun is just a dot here, a memory. Pluto doesn't warm you, but it moves you. And you realize something quietly absurd: sometimes the smallest things in the solar system hold the biggest mysteries. You've left Pluto now, but don't exhale just yet. The solar system doesn't end with the last planet or the former planet. No, it stretches out into a twilight region that's less space and more cosmic attic. Welcome to the Kuiper Belt, a dusty ring of frozen leftovers that's way bigger, way weirder, and way more mysterious than you probably thought. Imagine a ring that starts just beyond Neptune and stretches hundreds of millions of kilometers into the void. This isn't a tidy circle, it's a chaotic sprawl. You're drifting through a cold swarm of icy bodies, most smaller than Pluto, tumbling in elongated, tilted orbits that make no sense unless you've had 5 cups of coffee and a degree in orbital mechanics. And here's the big twist: this region is bigger than you think. The Kuiper Belt isn't just a belt, it's a whole ice palace the size of a solar system suburb, stretching from about 30 AU to 55 AU astronomical units from the Sun. That's up to 5 billion miles away, and we've only scratched the surface. Right now, astronomers estimate there are over 100,000 objects in this icy graveyard that are at least 60 miles wide. But that number may be a laughably small guess. For every rock we see, there may be 1,000 more hiding in shadow, waiting for their moment. You drift past one now featureless, grayish, forgotten. A frozen potato with craters and grooves just existing. It doesn't have a name, only a designation. Like 2001 QWB322 or 2014 MU69, which sounds more like a Wi-Fi password than a celestial body. Here's your fun fact: some of these objects have moons. That's right, moonlets orbiting miniature ice worlds, orbiting the Sun in distant, freezing silence. Gravity never stops networking. One such object, Arakoth, formerly known as Ultima Thule, looks like 2 snowballs stuck together because that's basically what it is. New Horizons flew by it in 2019 after visiting Pluto. The images showed a contact binary, 2 small, icy worlds that slowly merged in a gentle cosmic hug about 4 billion years ago. It's not spectacular. It's not violent. It's strangely tender. But this is the Kuiper Belt's whole vibe. It's a region of things that almost became planets. Leftovers from the great solar system baking session. Think of it like a tray of cookies, where some blobs never got fully baked, still doughy, still frozen, still waiting. Scientists still debate what counts as a planet out here. Some of these objects, like Eris, Haumea, and Makemake, are large enough to rival Pluto. Some have atmospheres. Some spin so fast they've become egg-shaped. Some might even have subsurface oceans. We just don't know yet. The Kuiper Belt is like a vault filled with locked drawers, and we've only peeked into one or two. And while you float through this silent menagerie of almosts and maybes, you catch something shimmering out of the corner of your eye. A comet. Not the bright tail-swinging kind you see from Earth, but a raw, dormant body. A comet before it becomes dramatic. It's just a dark rock wrapped in ice waiting for a gravitational nudge to send it sunward, where it will sprout a blazing tail and streak through our skies like it owns the place. That's right. Many comets come from here. The Kuiper Belt is a deep freezer for potential comets. Push one the right way, and it becomes a streaking spectacle in your sky 10,000 years later. Irrelevant but lovely if you were standing on one of these Kuiper Belt objects in a very warm suit. Obviously, you'd see the sun as a tiny, bright star, just another spark in the darkness. Night and day wouldn't mean much. Shadows would be long and frozen, and everything would feel like a paused video, motionless, but still full of possibility. This place isn't for drama, it's for persistence. You float past more icy rocks, some tumbling, some locked in synchronized dance with companions. There's no sound out here, but somehow it doesn't feel empty. It feels slow, measured, like everything's just waiting. For heat, for gravity, for attention. And maybe that's the point. This isn't the edge of the solar system. It's the edge of the story we think we know. Out here beyond the Kuiper Belt, where the solar wind weakens and the sun's voice becomes a whisper, lies something even stranger. You're still drifting slower now through the loneliest suburbs of the solar system. And this is where things start sounding fake, but they're true. Because tonight, you learn that the sun isn't on fire. Yes, you heard that right. The giant blazing ball that lights up your world, chars your skin, and powers your toaster oven is not on fire. Not in the way you think. There's no oxygen out there to support combustion. The sun is not a bonfire. It's not even a big candle with rage issues. What it is a nuclear reactor. At its core, where temperatures soar to over 27 million degrees Fahrenheit, 15 million degrees Celsius, the sun crushes hydrogen atoms together to form helium. This process is called nuclear fusion, and it releases absurd amounts of energy. The sun has been doing this steadily for about 4-6 billion years, and it's only halfway through its life. So don't worry, your solar nightlight isn't going anywhere soon. Still, it's bizarre, isn't it? The brightest object in your sky isn't burning in the traditional sense. It's fusing. Which means, technically, when you feel sunshine on your skin, you're feeling the result of particles that were born in a nuclear soup at the sun's core, 100,000 years ago. That's right. It takes photons, the packets of light energy, up to 100,000 years to escape the dense core and reach the surface of the sun. And once they do, just 8 minutes to get from the surface to Earth. So next time you're outside feeling warm and smug in your sunglasses, remember that sunlight started its journey before Homo sapiens even figured out agriculture. You're bathing in very ancient light. Here's a strange and irrelevant truth. If the sun were replaced by a black hole of the same mass, Earth would keep orbiting it exactly the same way. It'd be dark, sure, very cold, very dead. But our path wouldn't change. Because the sun's gravity isn't about light, it's about mass. Gravity doesn't care if you glow or not. Still, the sun does more than light the day. Its gravity controls every planet, moon, and rock in the solar system. And its magnetic field, oh, it's enormous, like way beyond the planets. The solar magnetic field stretches into the heliosphere, a vast bubble that shields us from galactic cosmic rays. And that bubble, it's shaped more like a comet's tail than a perfect sphere. because the solar system is hurtling through space at about 450,000 miles per hour. That's right, you're moving even when you feel still. Earth orbits the Sun. The Sun orbits the center of the galaxy, and the whole solar system is flying like a cosmic bullet through the Milky Way. The Sun leaves a wake, and it breathes. Solar wind streams of charged particles flow out in all directions like a steady exhale. Sometimes the Sun hiccups. Solar flares erupt, and coronal mass ejections spew billions of tons of plasma toward the planets. When these hit Earth's magnetic field, they cause auroras, northern and southern lights that dance silently in the sky. But they can also fry satellites and knock out power grids. In 1859, a solar storm known as the Carrington event hit Earth so hard that telegraph lines caught fire. If something like that happened today, your internet phone and TikTok algorithm would vanish instantly. Scientists still debate how often massive solar storms occur and how prepared we really are for the next one. The Sun doesn't just warm you, it threatens you. But then again, it also nourishes. Every plant, every breath of air, every meal powered by sunlight. Even fossil fuels are ancient photosynthesis stored in carbon tombs. Without the Sun, we're not just cold, we're meaningless. You float now in a dream state, imagining the Sun from the outside. You see not a raging fireball, but a disciplined, glowing engine. A slow, steady burn of atomic patience. The surface is an ever-boiling sea of plasma looped with magnetic storms and sunspots. The outer atmosphere, the corona, is hotter than the surface itself, a mystery that baffles scientists to this day. Yes, scientists still debate why the corona reaches temperatures of millions of degrees. Theories involve magnetic reconnection wave heating and some plasma physics so intense it makes your brain feel like a microwaved marshmallow. But here's the strangest part of all. Even out here, even billions of miles from the core, you can feel it. Not heat, not light, but presence. The Sun isn't just a ball of hydrogen. It's the gravitational heart of your cosmic neighborhood. And out here, where the planets end and mystery begins, you can almost hear it humming. Softly, steadily, still fusing. Now you've seen the planets. You've passed the floating ice worlds and the nuclear core of your sky dad. But tonight, let's jump just a little farther, just far enough to remind you how wild things can get when you're not confined to Earth-think. Because beyond the Sun and its family and the lightless, lonely dark, there are exoplanets. And one of them may be the most obnoxiously fabulous thing you've ever heard of, a planet made of diamonds. Yeah. Diamonds. Carbon compressed so hard, it becomes the hardest thing in the universe, and also the most popular choice for awkward engagement rings. This isn't science fiction. It's 55 Cancri E, an exoplanet, about 40 light-years from Earth in the constellation Cancer. It's about twice the size of Earth and 8 times as massive. And it orbits so close to its host star that a year lasts just 18 hours. Blink and it's Tuesday. But here's the sparkle: scientists believe its interior might be mostly carbon, and under that insane pressure, much of it could be diamond. Not scattered, not a few nuggets, like huge swaths of diamond stretching below a surface hot enough to vaporize iron. Now, before you call up Elon Musk with a mining proposal, take a breath. 55 Cancri E is not a place you want to visit. Surface temperatures can reach nearly 4,000 degrees to 200 degrees. There may be lava oceans. The heat from its nearby star is enough to turn your spacecraft into a puddle and your optimism into steam. Still, the Diamond Planet is a fascinating thought experiment. And not even a lonely one. Scientists have identified several other carbon-rich exoplanets that could be hiding similar treasure. These aren't exactly in our solar system, but they've reshaped how we think about planetary formation even around our own star. Because once you accept that a planet can be made of diamonds, you start looking at the solar system sideways. What else is possible? Take moons, for example. Back home, Earth's moon seems special because it is. But in the outer solar system, there are moons that rival planets. Some may even be more interesting than the planets they orbit. And you know what's really strange? Some moons might have moons. Yes, moons of moons. Or at least temporary companions orbiting small objects in complicated dances that stretch the definition of satellite until it breaks. Scientists still debate whether a moon can have a stable moon of its own. Gravity, after all, is picky. If you're too close to the parent planet, tidal forces rip tiny orbiters away. But if you're far enough and slow enough, it's theoretically possible. There are a few cases that almost count. In 2018, researchers observed a mini-object near 130 Electra, a large asteroid with multiple tiny satellites. The smallest was just 1.6 kilometers wide, barely a rock with an attitude, but it danced around a bigger satellite, making some headlines as a possible moon of a moon. Is it permanent? Maybe not. It might be a brief fling in gravitational terms, a cosmic summer romance. But even that possibility opens doors. Our own moon could have once captured a companion, or lost one. We just can't prove it yet. Then there's Saturn's moon Daphnis, which orbits within the planet's rings. It stirs the ring material around it, like a spoon in coffee, creating waves and gaps. Some scientists believe small ring particles might orbit around Daphnis, temporarily influenced by its gravity before rejoining the rings. Moonlets circling a moonlet. It's gravitational jazz. Here's your beautifully irrelevant fact of the evening: if you shrunk the solar system down so the sun was the size of a grapefruit, Earth would be a grain of sand 50 feet away. Jupiter would be a marble across the street, and Pluto a speck halfway across the city. That's how empty and how precise space really is. And in that vast emptiness, planets made of diamonds are real. Moons might flirt with other moons, and the lines between categories blur like chalk on a blackboard. You hover now in an imaginary place, a quiet pocket of nothing between stars, thinking about 55 Cancri A. It's blazing, boiling, possibly glistening beneath the pressure of its own brilliance. And you realize our solar system isn't the rule. It's just one of many bizarre, unlikely stories in a universe that specializes in, wait, what? The deeper you go, the less rigid the rules become. Planets burn, moons hide oceans, stars fuse quietly for eons. And diamonds, they might just be a common flooring option in the right stellar neighborhood. You ease back into our own solar system now, a little dizzy from the diamond dreamscapes and moon-on-moon drama. But don't get too comfortable, because the weird is still very much in session. Tonight we're talking about Saturn's rings, but not just how they sparkle or make your desktop wallpaper look celestial. No, tonight we talk about the twist they're babies. Saturn's rings are young, like shockingly young. For centuries we assumed the rings had been around since the dawn of the solar system. Big, elegant, ancient. But recent data from the Cassini spacecraft has shaken that idea like a snow globe. Saturn's rings may have formed only 100 million years ago. Yep, just around the time Earth was home to T-Rex giant ferns and the great "Why Are All the Birds Yelling" soundtrack of the Cretaceous period. Imagine that. When dinosaurs ruled the Earth, Saturn's rings may have been brand new, sparkling raw, maybe even brighter than they are now. Back then, somewhere in Saturn's domain, a moon, or perhaps several, got too close. Gravitational forces shredded them apart, creating that stunning halo of icy debris. Scientists still debate the exact process. Was it a single catastrophic event? A slow grind? Could Saturn have gobbled up a wayward comet or two? One theory suggests an ancient, unstable moon, nicknamed Chrysalis, may have drifted too close, been torn apart by tidal forces, and sprinkled itself across the planet's equator in a glorious, glimmering finale. Cassini helped us age the rings by measuring how much ring rain falls into Saturn's atmosphere, tiny bits of ice and dust slowly pulled down by gravity and magnetic forces. Based on that data, the rings appear to be decaying faster than we thought, which means not only are they young, they're temporary. Yep, the rings are disappearing. Someday they'll be gone. Not overnight, but over tens or hundreds of millions of years, the rings will erode, vanish, and leave Saturn looking, well, a little naked. Still majestic, but a little less Instagrammable. It's like realizing the Mona Lisa is actually a limited-time exhibit, a cosmic installation piece caught in the brief golden hour of Saturn's evolution. Here's your oddball fact for the night: the rings, when seen edge-on from Earth during Saturn's orbit, can disappear completely from view. They're so thin sometimes, only 10 meters thick, that when tilted just right, they vanish like a magician's card trick. Saturn becomes a ringless orb just for a moment. And if you've ever looked at them through a telescope during one of these alignments, you've seen something very few people on Earth notice: Saturn's rings are not permanent even to the eye. But there's more. Because it's not just about Saturn. The story of its rings reframes how we think about planetary beauty. We used to believe Saturn was born elegant, an ancient king with icy armor. But now we realize elegance can be an accident. Beauty can be the result of destruction. Tragedy can sparkle. You float above the rings, now skimming just meters above the icy rubble. Each piece reflects the sun in its own way, some sharp, some soft. Some are as small as marbles, others as large as houses. They orbit Saturn in a perfect ballet, each rock keeping its own rhythm, held in place by gravity and resonance. And even here you feel something gentle, almost bittersweet. These rings won't last forever. You're watching a phase, a moment, a planetary adolescence. Saturn will grow out of it. Maybe it's already started, but for now the rings still shine. You glance down, seeing the shadows they cast on Saturn's cloud tops, ghostly, concentric, like ripples in time. And above, the stars remain silent, uncaring, beautiful. You remember Earth was once covered in rings too, for a brief moment after the moon formed. And it might happen again someday in some future collision when a moon or asteroid breaks apart. Maybe Earth's skies will once again hold a shimmering halo, and some far future creature will look up and think, that's always been there. But no, rings are temporary, even Saturn's. Let's stay with Saturn just a bit longer, because we're not finished with the surprises. You've admired the rings. You've floated above the hexagonal storm. But now it's time to peer into the heart of the gas giant itself, and what you'll find might just mess with your entire concept of stars and planets. Here's tonight's truth. Jupiter isn't the only planet that almost became a star. Saturn, too, nearly lit up. That's right. Saturn could have been a sun. It tried. It just didn't quite make the cut. See, the only thing that separates a gas giant from a star is mass. If Saturn had been about 75 times more massive, it would have achieved enough gravitational compression at its core to start nuclear fusion, just like the sun. But it stopped short, maybe mercifully, because otherwise our solar system would be a wildly different place. You wouldn't be here. Earth might not exist at all. Instead, Saturn became what scientists call a failed star, a glorious glowing almost, still enormous, still powerful, but dark, like a candle that never caught flame. And while Jupiter gets most of the attention for being the almost star, Saturn has a case too. Inside its core is dense, hot, and radiating twice as much heat as it receives from the sun. That's right, Saturn glows. not visibly, but in the infrared. It gives off heat like an ancient oven that never bakes but never cools. Scientists still debate the exact structure of Saturn's interior. Some models suggest a solid rocky core surrounded by layers of metallic hydrogen and helium. Others propose there's no clear boundary at all, just a swirling soup of compressed gas and exotic matter. It's like trying to model a thunderstorm inside a snow globe while blindfolded. But one thing is certain, Saturn is leaking helium. Yes, it's raining on itself. In the upper atmosphere, helium condenses and falls inward like shimmering droplets. This helium rain releases heat as it sinks, helping power Saturn's internal glow. Imagine standing inside a gas giant while it quietly, invisibly rains liquid helium. Not scary, just surreal. Here's your delightfully irrelevant fact: if you could place Saturn in a bathtub, yes. We're doing this again. Its helium rain would never reach the bottom. It would just swirl forever in pressurized layers, sinking deeper and deeper into a never-ending glowing cloud parfait. And now here's the truly poetic twist. Even though Saturn never became a star, it behaves like one in some ways. Its magnetic field is shockingly strong, comparable in strength to Earth's, but generated by completely different materials and mechanics. Its field lines create auroras at the poles, just like on Jupiter and Earth, painting the upper atmosphere with flickers of ghost light. And those auroras, they're not just from the sun. They're also powered by Saturn's moons. Specifically Enceladus, which we'll get to soon, is constantly spraying material into Saturn's magnetosphere, fueling the planet's electric personality. So in a weird way, Saturn is fed by its children. Its inner light, its magnetic dances, its wild storms, all fueled by internal gravity and the influence of its orbiting family. You float now just above the clouds, watching the golden surface ripple and roll. Thunderheads pile hundreds of kilometers tall. Winds reach 100 mph faster than Earth's strongest hurricanes. But there's no thunder, no sound, just motion. Continuous swirling motion. It's easy to forget this thing isn't solid, that beneath those clouds there's no ground, just more layers, more pressure, more heat. The deeper you go, the more lost you become in a labyrinth of hydrogen behaving like metal helium turning to rain and gravity pressing everything toward a glowing, uncertain core. You're floating above something that wanted to be a star. That almost was. That still remembers what fusion feels like even if it never quite arrived. And isn't that kind of beautiful to almost be something and still be magnificent? You don't need to ignite to shine. Let's zoom in now, not on a planet, not on a star, but on something that stinks, literally. Tonight, you're face to face with one of the solar system's most unexpected facts. Comets smell like rotten eggs and cat pee. Yep, you didn't mishear that. If you could bottle the essence of a comet, you'd have something truly cursed. An aroma best described as a mix of hydrogen sulfide, that's the rotten eggs part, ammonia, high litter box, formaldehyde, and methanol, with just a dash of bitter almond cyanide if you're lucky. It's like the worst cocktail bar in the galaxy. And yet, this horrible stench might also be the smell of life's building blocks. You float now beside a comet, a big one. A deep space snowball like 67P Churyumov-Gerasimenko, the one visited by the European Space Agency's Rosetta mission. It's shaped like a weird rubber duck with cliffs and jets and crusty surface ridges. And it's active. Even out here, far from the sun, it's leaking gas and dust from its porous skin like a hissing tea kettle. Comets are dirty snowballs, frozen chunks of rock ice, and complex organic molecules left over from the birth of the solar system. They live in the Kuiper Belt, or the distant Oort cloud, and sometimes, thanks to gravitational nudges, they come flying inward. When they get close enough to the sun, Heat begins to vaporize their surfaces, creating tails that stretch for millions of miles. And that's when they start to smell. Rosetta carried a little instrument called Rosina, which sniffed the comet's emissions and returned a recipe that reads like a science experiment gone off the rails. Scientists still debate exactly how all these molecules formed, whether deep in the early solar nebula or on the surfaces of tiny icy grains that stuck together. But the implications are wild. Because here's the twist: comets might have seeded Earth with ingredients for life. That's right. The water in your veins, the carbon in your cells, the amino acids in your midnight snack. They may have come from one of these smelly, grimy travelers billions of years ago. As comets slammed into early Earth, they might have delivered essential chemistry building blocks, prebiotic stew, or even the molecules that eventually turned into you. It's the solar system's most disgusting origin story. Life may have started with space garbage. And there's more. Comets have two tails, one made of dust, one made of gas. The dust tail curves gently following the comet's orbit, but the gas tail shoots straight outward, blown back by the solar wind like an invisible blow-dryer. If you could stand on a comet, you'd fall off, you'd see the sun rising behind you and two ghostly tails streaming away like flags in a wind that makes no sound. You float beside one now. It's haunting. It's beautiful. It smells awful. And it doesn't care. Irrelevant but delightful fact of the night: comets have seasons. Depending on their orbit, different parts of their surface get exposed to the sun. This means their jets of gas and dust can erupt in new places, each orbit changing their appearance like a rotating spotlight in a haunted house. Some comets even break apart under thermal stress, cracking, crumbling, and vanishing into glittering trails. One comet, Shoemaker-Levy 9, famously broke into 21 pieces and slammed into Jupiter in 1994, causing fireballs bigger than Earth and visible scars in the gas giant's clouds. It was a spectacular reminder: comets might be dirty snowballs, but they hit like wrecking balls. Scientists still debate how many comets are out there and how often they've rewritten history. Some researchers believe comet impacts helped cause mass extinctions or even altered Earth's climate. Others argue that future comet strikes are inevitable and that somewhere a rogue chunk of ice might already be headed our way. Comforting, isn't it? But tonight, none of that matters. You're floating in a silent ballet beside a comet that's shedding its skin to sunlight. You watch as particles glimmer like powdered diamonds, scattering behind it into a trail that will linger long after it passes. The tail is miles long. The journey took eons. And the stink. It's cosmic cologne, foul, ancient, and full of secrets. This little frozen punk of a rock may hold clues to where you came from. So breathe in metaphorically, please, and savor the fact that space doesn't smell like vanilla. It smells like potential. So far, we've smelled a comet hovered above icy moons and watched Saturn nearly become a star. But now we return to one of the solar system's loudest whispers, a planet we once dismissed as hellish, dull, and dead. Tonight we revisit Venus, and this time we're asking a fiery question: could Venus still be alive? Not alive with palm trees and polite aliens, mind you, but geologically alive. As in active volcanoes possibly erupting right now beneath those thick sulfuric clouds. For decades, scientists assumed Venus had long since cooled into a geologic fossil. Its surface is a scorched wasteland of basalt plains, collapsed lava domes, and ridged plateaus, all seemingly ancient, all baked in atmospheric pressure that's 92 times what you're used to. That's the equivalent of being 3,000 feet underwater while also on fire. Venus, the sauna nobody asked for. But then came the hints. Images from past missions like Magellan in the 1990s revealed puzzling patterns: fresh-looking lava flows, surface formations that lacked cratering, suggesting they might be new. And in 2020, scientists went back through old radar data and noticed something strange: a volcanic vent had changed shape over time. That's right. Between 1991 and 1993, something on Venus moved. Cue the scientific eyebrow raise. In 2023, another study piled on, presenting direct evidence of active volcanism. A vent in the Mont Mons region appeared to collapse and fill, likely from an eruption. A volcano burped. On Venus, in your lifetime. And now the once dismissed death planet might be very much alive, geologically speaking. Scientists still debate the extent of Venus's activity. Some think it's constantly reshaping itself in lava-fueled tantrums. Others think the occasional puff of magma might be all we get. But the idea that Earth's twisted twin is still moving, still heating, still simmering under its toxic shell, that changes everything. It means Venus isn't a graveyard. It's a pressure cooker, a molten ballet behind a curtain of clouds. Venus might even still have a form of plate tectonics. Not like Earth's cracking puzzle pieces, but a sluggish system of crustal overturning, where entire sections of the surface might sink into the mantle, replaced by fresh lava plains. It's tectonics in slow motion, in pain, but it's movement nonetheless. Here's your oddly wonderful fact of the night. Because of its atmosphere and rotation, a day on Venus is shorter than its year if you count the solar day, the time it takes the sun to return to the same position in the sky. That's because Venus rotates backwards slowly, and its thick clouds whip around the planet in just 4 Earth days. So if you stood on Venus again, the sky would circle you like a racetrack, while the ground barely bothered to turn. And now let's talk sound. You can't hear anything on most planets, no air, no sound. But Venus has a dense atmosphere. Sound would carry here. You could talk assuming you weren't melting or crushed, and your voice would sound deeper, slower, like someone turned down the pitch. Venus would auto-tune you into a lounge singer. That makes it one of the few places in the solar system where you could actually whisper. Irrelevant bonus. If you dropped a spoon on Venus, it would fall slower than on Earth, despite the high gravity, because the atmosphere is so thick it resists movement. It's like trying to run through syrup. Burning acidic syrup. So yes, Venus may still have volcanoes. It may still be reshaping itself while no one watches. Beneath that constant cloud cover, it might even have lava lakes, vents, gas plumes, or regions that glow faintly in infrared. And we won't know for sure until we go back. New missions are coming. Veritas and Da Vinci, both planned by NASA, may finally give us a clear look under the veil. High-resolution radar maps, atmospheric sampling, even landers, Venus might finally start telling us what it's been hiding for billions of years. You float now just above those eternal clouds. The sky is pale yellow, thick and oily. Lightning flickers below, quiet, menacing. Somewhere beneath lava might be bubbling, reshaping an ancient land no one has seen since before Earth had continents. And you think this place was once like Earth. This place might still be changing. This place might rise again. Let's step away from the lava seas and acid clouds and wander somewhere. Haunted. You drift toward Mars again, not for the red dust or Olympus Mons or frozen polar caps, but for something more subtle, something stranger. You're here tonight to listen. Because guess what? Mars sounds like a haunted house. It's not a metaphor. NASA's InSight lander, which touched down on Mars in 2018, brought with it a highly sensitive seismometer and a microphone. What it recorded was a symphony of creaks, groans, howls, and sighs. The red planet moans in frequencies that can only be described as unsettling. Wind scraping over barren rock, seismic tremors echoing beneath dry crust, and sometimes strange mechanical clinks that make the lander sound like it's being watched. The first Martian sound ever recorded: wind. Pure alien wind blowing at about 10 to 15 POIs across an empty plain. It wasn't violent, it wasn't dramatic, but it had a texture like someone exhaling through cracked lips in a long-forgotten temple. And that was just the beginning. InSight recorded Marsquakes, the Martian equivalent of earthquakes. Unlike Earth, Mars doesn't have shifting tectonic plates, but it does have pressure, cracking, cooled lava crusts that shift as the interior shrinks and cools. These quakes are tiny, but they travel far, and they sound eerie. One quake was so low frequency and odd that scientists nicknamed it the Dinks and Donks event. Seriously, the planet actually went dink, then it went donk. It wasn't a bug, it wasn't a glitch. It was the sound of stress within a world that's still breathing just barely in the vacuum of time. Scientists still debate the source of some of these sounds. Thermal contraction, crustal cracking, rock falls, ghosts of disappointed Martian civilizations that never were okay. That last one's less popular in peer-reviewed journals. But the fact remains, Mars is not silent. Even the wind is weird. It doesn't just whoosh, it rumbles. Because of the thin atmosphere, sound travels differently. High-pitched sounds are lost quickly, while low-frequency vibrations carry farther. If you tried to speak to someone just a few meters away, they might not hear your voice, but they'd hear your breath, your footsteps, your backpack creaking like an old coffin. And here's an oddball fact for you: sound moves slower on Mars. And not just slower overall, there are actually two sound speeds. High-pitched noises move at one speed, low-pitched at another because of how carbon dioxide molecules interact. It's like the atmosphere is processing sound through a glitchy filter. If Earth is a symphony hall, Mars is an abandoned vinyl shop with a warped record playing in the back room. So yes, Mars is a haunted house. But instead of ghosts, it's haunted by geology, by cooling, by contraction, by the weight of memories too old to name. You float now over Elysium Planitia, where InSight rests half-buried in red dust. The sun is low, shadows stretch long, and the quiet. It's not really quiet at all. Below the surface, the land is groaning, the rocks are whispering. The wind is dragging its fingers across the plains, like it's searching for something. You close your eyes and listen. A soft creak, a faint ping, then a low, long hum, maybe from the wind, maybe from the planet itself. There's a loneliness here that isn't empty. It's full, heavy, like Mars knows it was once wetter, warmer, more alive. And now it just sighs in its sleep, dreaming of oceans that have turned to ghosts. NASA's lander will go quiet eventually. The solar panels will fill with dust, and the whispering will fade. But the planet will keep making noises. Because even a dying world doesn't go silently. It groans. It cracks. It waits. You leave behind the sighing plains of Mars and drift towards something stranger, wetter, and very much alive in the icy dark beneath the rings of Saturn. You're headed for Enceladus, one of Saturn's smaller moons. But don't let its size fool you. This isn't just a frozen marble floating through space. This is one of the most active, mysterious, and potentially habitable places in the entire solar system. Because Enceladus is spraying its ocean into space. Let's start with the setting. The moon is just 313 miles, 504 kilometers wide, about the size of England. Its surface is blindingly white, one of the most reflective in the solar system, coated in fresh, clean ice. But that pretty shell hides something deep and wild, a global subsurface ocean, kept liquid by tidal forces from Saturn's gravity. Think of it as a watery heart pumping beneath a crust of frozen silence. And the proof, it's coming out in geysers. Back in 2005, NASA's Cassini spacecraft flew past Enceladus and saw it plumes of water vapor ice particles and organic molecules blasting from cracks near the moon's south pole. These cracks were later nicknamed the Tiger Stripes, four parallel fissures stretching across the ice like scars on an ancient snow beast. Cassini flew through those plumes, not over them, through them. And what did it find? Salty water, methane, molecular hydrogen, tiny grains of silica, complex organics, all the stuff you need for a decent recipe of habitability. In fact, the presence of hydrogen hinted at something extraordinary: hydrothermal vents on the ocean floor, just like the ones on Earth where life first formed. Let that sink in. There might be boiling mineral-rich water flowing through rocky vents in the ocean under Enceladus's icy shell right now. If anything lives there, tiny microbes, weird alien plankton, deep-sea space squids, we might be able to sample them without even landing. Just fly through the plume again and scoop up the evidence. Scientists still debate how deep and active that ocean really is, how long it's been there, and how isolated it might be. But the basic fact is now settled. Enceladus is hiding an alien sea. And that sea is not still. It's spraying its secrets into the void. Let's take a moment for a side fact that's oddly perfect. The material Enceladus ejects doesn't just vanish. It becomes part of Saturn's E-ring, a faint, wide ring that literally exists because a moon keeps sneezing water into it. So the ring around Saturn, it's a fingerprint from an internal ocean. You drift now above the South Pole. It's eerily beautiful. There's no sound, no light until one of the plumes erupts beneath you. A glowing misty fountain, tens of miles high, glowing faintly in the starlight. If you had a cup, you could collect it. You float through the mist and imagine what might be living in the ocean below. Not fish, probably, but microbes, maybe. The chemistry is there, the warmth is there, the pressure is there. The only thing missing is a definitive yes. Irrelevant fact: if you could stand on Enceladus and jump, you'd never come down. Well, you would eventually. But the gravity is so low that with a strong enough hop, you could escape the moon entirely. It's only about 1% of Earth's gravity. It would feel like walking through a dream or skating on a ghost. And that ghost would whisper, "Something is alive under here." Enceladus isn't flashy. It's not massive like Jupiter's moons. It doesn't have volcanoes or glowing surfaces. But what it does have is plausibility. It has the best, most accessible chance of finding life beyond Earth without drilling or digging or flying to another star. Just one mission, one sample return, and the answer might be floating out here already. You hang above the Tiger Stripes, watching mist curl into the void like breath on a winter morning. Below your feet, miles of ice, then water, then stone. And maybe something watching back. You pull away from Enceladus mist, still clinging to your suit like a memory. Out here in the dim light of the outer solar system, everything feels slower, quieter, colder. But don't let the calm fool you. You're entering the realm of ancient leftovers, a place not quite planet, not quite empty space. A frozen graveyard stretching beyond Neptune, past Pluto, past what most people think of as the solar system. Welcome to the Kuiper Belt again, but this time we're talking scale, because it's much, much bigger than you think. We tend to imagine the solar system as ending with Pluto. Nice tidy round. Nope. In truth, Pluto is just the inner edge of a vast debris field, a disk of icy bodies stretching billions of kilometers beyond. And the Kuiper Belt, it's huge. How huge? Think of the distance between Earth and the Sun. We call that one astronomical unit, or 1 AU. Neptune orbits at around 30 AU. Pluto orbits between 30 and 50 AU. The Kuiper Belt stretches from 30 AU to over 55 AU, and maybe beyond that. That's a ring of icy objects 3.5 billion miles wide. And Pluto? It's just one relatively large snowflake in a blizzard of frozen leftovers. Thousands of objects reside here. Some are as small as cities. Some, like Eris Makemake and Haumea, rival Pluto in size and complexity. Some spin rapidly and are stretched into weird shapes. Some have moons. And some are so far and so dark we've only just started detecting them. Scientists still debate where the Kuiper Belt ends and the scattered disk or inner Oort cloud begins. Because unlike a neat planetary orbit, this is a region of chaos. Eccentric orbits, tilted paths, objects swinging in and out like dancers who never learned the choreography. Irrelevant but charming fact, if you stood on one of the bigger Kuiper Belt objects, say Haumea, you'd see the sun as just the brightest star in the sky, not a disk. The light would be daylightish, sure, but it wouldn't warm your face. It would barely cast a shadow. And here's the eerie thing: the Kuiper Belt is still interacting with the inner solar system. Every once in a while, an object gets nudged by Neptune's gravity, by another body, or by time itself, and starts drifting inward. Over millennia, it might become a short-period comet visiting the inner solar system again and again, like a moth to a flame. Some of the comets we've seen are migrants from this very region. So what lives out here? Well, life in the traditional sense. Probably not. It's cold around 400 degrees. There's no sunlight, no atmosphere, no tectonics. But in terms of structure, it's fascinating. Some of these objects are binary two bodies orbiting a common center. Some tumble. Some are locked into orbital resonance with Neptune. It's not lifeless. It's alive with motion. And then there's Arrokoth, the most distant world ever visited by a spacecraft, courtesy of New Horizons in 2019. Arrokoth looks like two pancakes stuck together. It's red. It's smooth. It's ancient, essentially unchanged since the dawn of the solar system. Scientists still debate how such a delicate object survived the chaos of planetary formation. Some think it represents the very building blocks that formed Earth and everything on it. You're not just looking at a snowball. You're looking at a time capsule from 4.6 billion years ago. You float now between these bodies, the stars sharp and bright around you. There's no horizon, no sound, just endless icy silence. And yet you feel surrounded not by danger, but by stories. Every object here is a story the planets never finished writing. Pieces of a cosmic draft that didn't make it into the final version. And what's beyond this belt? Well, that's where the questions get bigger. There's the Oort cloud, perhaps. Or Planet 9, maybe? Or perhaps nothing at all. But that's for next time. Tonight you drift past the edge of Pluto through the frozen relics of a time before time. You watch them spin slowly, patiently beneath the ghost light of a forgotten sun. And you realize the solar system didn't end. It just became quiet. The last stretch of our journey takes us to the mysterious frontier, the shadowy edge of the solar system, where secrets gather and whispers become legends. Here, where the faintest traces of the sun's influence fade into the abyss, astronomers suspect a giant Planet X or Planet 9 lurks in the dark. You can't see it, of course. Not yet. But the evidence is there, subtle and unsettling. Several distant Kuiper Belt objects follow orbits that seem too orderly, too aligned to be random. Their paths suggest the gravitational pull of a massive unseen planet, something several times the mass of Earth orbiting far beyond Neptune, perhaps thousands of times farther from the sun than we are. Scientists still debate whether this hidden world exists or is just a trick of data and gravity. Some say it's a mirage, an artifact of incomplete observations. Others argue it's waiting patiently orbiting the sun on a vast, slow ellipse, keeping itself well hidden. Imagine what it would mean if it's real. A giant planet, cold and dark, wandering the outer darkness alone. It could be a remnant from the early solar system kicked out from the inner planets during a chaotic youth. Or it might have been captured from another star passing close, a cosmic refugee. And if it's there, it might explain some of the oddities we see, like the tilted orbits of some distant objects, or the strange clustering of comet paths. The concept of Planet X isn't new. Astronomers have hunted for it for over a century. But now, with more powerful telescopes and advanced surveys, the hunt is more serious than ever. A discovery would reshape our understanding of the solar system's architecture and our place within it. Irrelevant but thrilling fact, some theories even suggest Planet 9 could have moons of its own, potentially icy worlds with hidden oceans. If so, our solar system's outer reaches might be more habitable than we ever imagined. You float in the cold void, imagining the vastness around you, a realm where light barely penetrates, where time stretches, and where mysteries multiply. The sun, a distant candle, the planets, familiar dancers, and beyond, a dark stranger possibly waiting to be found. You feel small, yes, but you also feel connected to the search, to the wonder, to the unknown. And that's the true magic of the solar system. Not its size, not its heat or storms or shining faces, but its endless capacity to surprise. You take a deep breath, softer, now slower. The stars fade gently as your eyes close. The journey ends, but the story, it's just beginning.